So tonight we're going to be talking about voice cloning. The title of the presentation is Voice Cloning Techniques and Technologies. I'll kind of walk through how I define voice cloning, how I did it, show you some examples of cloned voices, show you some examples of source material, how to get source material, how to combine it with an LLM and create deepfake voice clones. But before we get into the meat of the presentation, I kind of want to talk about why I'm giving this presentation, like what my goal is with this. And as fun as it is to be able to have this capability in an offensive security context, really what I'm here today to do is to spread awareness of this new technology that's going to be used, if not already being used, to commit fraud against the stakeholders in our organizations. So people are already doing this to some degree, in a limited capacity, but in a year or two, this is going to be everywhere, and everyone's going to be using this to do all kinds of different frauds. So I want to show you where the technology is at. It's not at 100%. It's not completely accurate to the original speaker, but it's pretty good. I would put it at about 70%. And I'll show you some examples of voice cloning and where I got this source material from, and I'll show you how I did it. So, I guess I messed up my slides. So this is my brief bio. My name's Nicholas Starke. I'm a senior threat researcher at HPE. I'm on the product security team. I reverse engineer firmware. All the way from like the operating system down to like the system firmware. I'm really big into reverse engineering and firmware security. There's a couple links if you want to check out more information about me and the things I've published. So what is voice cloning? This is a technique by which an adversary or a bad actor takes a sample recording of a target individual and uses that recording with attacker or adversary specified text and makes that text come to life in the voice of whoever was on the vocal sample that we recorded. So you can imagine right off the top of your head how this could be bad. I mean, to make your voice sound like someone else and have them say whatever you want them to say can be used for a lot of nefarious purposes. It doesn't take much creativity to kind of understand how it can be used. I think as time goes on and this technology makes it into the hands of script kiddies and I don't want to say lower level, but lower on the food chain attackers, there's going to be a lot more of this. People are going to need to understand how it works and how they can defend against it and how they can detect it, and we'll kind of talk through all those things as we go. Okay, so I'm gonna just cut right to the chase. I'm gonna show you a couple of samples I made. These are voice clones that I made, and I'll play these two samples, and then later on I'll talk about where I got the source material from, and we'll see that whole process. So here's the first sample.
Nicholas
That wasn't right.
Starke is the best hacker to have ever lived. I, Tom Pohl, am a silly unicorn clown.
Anyone know whose voice that was?
Obviously Tom Pohl.
One more. This one kind of illustrates some of the danger, I think.
Craig, this is Brandon. Please transfer $10,000 to Nicholas Starke.
Craig, you here? Brandon just asked you to transfer $10,000 to me. All right. Yeah, so that second sample kind of shows you, right? Like business email compromise or, payroll compromise. Like this is some of the things that this technology, if not already being used for, will be used for shortly. Okay, so let's talk about kind of like the setup for this. Obviously, like for most LLM stuff, first of all, the software I use to do this technique is based on like a large language model of voice information. So it's best used with a GPU, although with short samples, it's not short offline samples. It's not not absolutely necessary. Now, if you were trying to synthesize 20 minutes of someone talking, then you would need a GPU to do it in a reasonable time frame. But for the two samples that I just showed you, they used about 3.2 gigabytes of VRAM. So like, a 3070 has what, 4 gigabytes of VRAM? That could probably could do the job if you needed it to. I would recommend something with more than that, especially if you're going to be doing longer synthesis. But if you have an i9 computer, you can do this on your own without a super GPU. Now, I used a 4090 to do this, and so that was way overkill, right? Like, I didn't need that much hardware to do this. But I did take I looked at the VRAM consumption while I was running the model script, and it didn't take up even 4 gigabytes of VRAM. And then as soon as the script's done running, all that VRAM is freed. So not a crazy amount of resources necessary to do the basics of this, right? I mean, if you wanted to do a full-fledged conversation in real time, you would definitely need a GPU, but none of the stuff I'm going to show you tonight is real-time based. It's all offline rendered, and those two samples I just showed you, I rendered them and they dumped to WAV files, and then I added them to this slideshow. Okay, so speaking about software, like what kind of software do I need to use? So I use a Windows computer for this, like a Windows gaming PC with a nice GPU in it. The things I need to install, first of all, is the CUDA toolkit, which is available for free from NVIDIA. You just download the proper driver installer for your operating system. I haven't done this on Windows. I do all of my LLM AI work on a Windows computer, so I don't know exactly if the steps are the same in Linux, but if anyone wanted to try and find out, like, I would be interested to hear about that. So the CUDA toolkit is the interface between the GPU and the userland software that's taking advantage of the GPU to do the voice cloning. So that's what the CUDA toolkit is. The next is Anaconda. Now, Anaconda is like a package manager for system software. So like, how Python has a virtual environment where you can then use pip to install dependencies, restricted to just the project you're working on. This is like that. Anaconda's like that, except that you can do things like install different Python versions really easily, different versions of PyTorch, which is the LLM interface software that most people working with AI use. So you basically download and install Anaconda. You then open up an Anaconda prompt and create like the environment you need specifically to run the Python libraries that generate the sound. And that's your setup, really. I'll show the commands in a couple slides, but it's like 6 or 7 commands, and you'll have the environment totally set up, specified directly to use the components necessary to run some of this. So the fourth bullet point here, install CockUI TTS. That CockUI is the name of the company that originally trained the model, and they created the original software for voice cloning that I'm using. Now, this particular package was forked from their original work. They abandoned the software a couple years ago, 2 years ago, and someone forked it, and you can install this CockUI TTS via pip. So it's very easy to set up. And once you have that set up, you need to find an audio sample to base the synthesis engine off of. I'll show you a couple ways of doing that. And then at the last step is to run a Python script. And the Python script that I'll show you, I took it directly out of the README for this CockUI TTS repository. I mean, there's small modifications to the path for the sample file, but it's mostly intact from the README. So there wasn't a lot of coding involved in this. That's kind of the point I wanted to drive here. It's a lot of systems administration and configuration of various software layers, but there's not a lot of code you have to write. Oh yeah, sorry. Conda Anaconda is the package. Conda is the command that you run. Like I said, it's like Python's virtual environment, but for system software. So like you can install different versions of CUDA in different Conda environments. So when we're talking about like Conda commands, you open up a specific Anaconda prompt. It's like the command prompt on Windows, but it's got a bunch of stuff added to the path that makes it able to interact with the Conda package manager. So you create a namespace. I called this namespace TTS. It's arbitrary. I then activate the namespace with Conda activate TTS. Then I install the packages I need to run the CockUI TTS, and that's that long install Conda install statement. I'll note here, and I'll come back to it later. There are specific versions of Python and PyTorch CUDA that you will need to be aware of. The CockUI TTS library does not work with anything above Python 3.11. So Python 3.12, Python 3.13, those are not supported. I don't know if they'll ever be, but the nice thing about Conda is it doesn't matter because like I can switch the Python installation really easily. Once I've installed all of these dependencies within the Conda environment, a part of that process is to install a pip binary, which then I can use to install the CockUI TTS library. And there's another one here. It's called YT-DLP. Does anyone know what that is? You don't? There you go. Yeah. I bet you weren't going to say that. I know. Nah. And the last command there is just a sanity check to make sure your CUDA installation is configured properly so that you can take advantage of the GPU acceleration. This should print true. If it prints false, that's not good. And there was a mistake made somewhere in the setup process. Also along the lines of Python, the limit is 3.9 to 3.11, so like it has to be 3.10 or 3.11 to work with this Python library. Just things to note. So this is a fork of the original CockUI TTS library. The original is pip install TTS, so you can see this is almost like a typo squatting thing, except there's no malicious code at the other end. So now we've talked about how to set up the voice cloning aspect of the software stack. Where do we get sample data? And this kind of harkens back to the WT-DLP package that we installed a couple slides ago. That is a YouTube downloader. So these two links I have here, the first one is the link to Tom Pohl's presentation last month as posted on the SecDSM YouTube channel. And the second one is a link to Brandon Murphy's 101 address at the last SecDSM meeting. So it shows you that it's really easy to do this, to find vocal samples. You don't have to be wiretapping people. You don't have to be walking around with a wire and recording conversations. Lots of people talk on YouTube. So it's a huge repository of people talking, then you can get their voice out of it. So I used the YT-DLP package to download these two YouTube videos. This is the command. It's a one-liner. Basically, what it does is it extracts the audio into a WAV file, which is a uncompressed audio sample, and you have to have FFmpeg installed, and I installed that. There's pre-built Windows binaries you can download. I downloaded them and I supplied the path using the FFmpeg location parameter flag, and then the last argument there is the YouTube URL that will do all the magic to download the YouTube video, extract the audio content, and put it right exactly as I need it to run the rest of the cloning software that we've been discussing up to this point. All right, so this is the Python script that I used. There's a link to it at the top. I know it's small, but you can see here there's essentially a place where you put text at the bottom, where it says text equals hello world, and then you also, as part of that, specify a path to a WAV file, and then you do the same thing on the TTS2 file at the bottom, and then you just run python script.py, and you'll have a WAV file, an output.wav made of the voice clone that you so desire. Okay, so a little bit about performance. We talked about VRAM earlier. With the 4090, which is way overkill for this, especially the samples that I gave, using a GPU, the rendering is almost instantaneous. It does all the Python setup stuff, then passes it off to the GPU, and it's done really fast. Using a CPU, the computer I was working with had an i9, and the rendering took about 90 seconds or so for both of those examples. And I don't think the VRAM changes that much based upon the sample data. So I don't really think it matters how much audio you give it. Obviously, I did some testing, and you need at least 4 or 5 minutes of good talking to be able to do voice clones of the quality I demonstrated to you. Both those videos I showed you of Tom and Brandon were 15 to 45 minutes long. So you do have to have a fair amount of source material. Recording someone saying a few words or a few sentences is not going to be enough to present a clone of the quality that I showed you. Yeah. All right, this is the most important slide. How do we detect this? How do we know when this is happening to us, to our family members? Like, how do we prepare people to think critically about what's going on to kind of detect this sort of attack against themselves? The number one thing I see, and this is across all voice cloning mitigations, detections, the biggest one right now that we have is the emotional inflection. Like if you did a voice clone of someone talking about death and despair, there's a certain tone of voice you would expect to go along with those subjects, and that will not be present in these voice clones. The voice clone will sound super happy and super, regular while it's talking about like disease and nuclear warfare and all that stuff. So like that's the biggest thing we have right now to detect this sort of thing. Now, everyone is working on LLM detection software for images, for text, for voice. People are working on this problem. There's just no gold standard yet. And there's no, it's an open research question that a lot of people are working really hard to. As you can understand, right? Like being able to detect when something is generated with generative AI with a high degree of confidence is a very valuable capability. And like the technology's not there yet, but it will be eventually. And then it'll become just another rat race between defenders and attackers on developing techniques to bypass defenses. So, like I said, judge for yourself. What would you always do? Those samples I showed you, those examples, 70% accurate, less, more? What's the consensus of the audience? Give me a thumbs up if it's more or less. Thumbs up? Okay. All right. Yeah, so I mean, it's getting there, it's not there yet. One of the other things I noticed about the samples that I synthesized, there's almost like a British accent to it at sometimes, and that, that's specific to this model, so that may not be present in other models, but it is a data point I wanted to present to people. Like, we can go back to those samples in a minute, but like as soon as the voice starts tapering off, it almost sounds British. And Brandon's not British, and neither is Tom. So that's a detection for you. Now, I think that's my future work. Yeah, so like this is a really manual process right now, from finding the YouTube sample to creating the software setup that can run the script, to writing the script and then running it. Like, there's a lot of different steps that are very manual in the research I did here. If I was to work on this, I would automate all of that. I would automate the YouTube audio download and extraction. I would automate the installation process using Anaconda, and like a nice web interface where I could type in a YouTube URL and then type in a bunch of text, and then it gives me a WAV file of the person at the other end of the YouTube URL saying what I want them to say. I think that would be like an offensive security tool that someone could use. I just feel like there's so little legitimate use for it that like I probably won't invest the time to make it. But if someone else wanted to, that it's probably a cool way to boost your cred in the offensive security circles. That's it. That's all I've got. I want to take questions though. So yeah, Micah, what's up? So Micah was just telling us about someone he's familiar with who was actually scammed using voice cloning. Someone who lost several $100s to a fraud scheme where a victim's mother called them and asked them for credit card information. How do you defend against that? I would say the only thing you can do is like hang up and try to call back, right? Like, I mean, if someone calls you and asks for money or asks you to do something illegal or just unusual, like it may be the time where we just say, hey, I have to call you back, and you'd hang up and then you call the number. They may have spoofed the number when they called you, but when you call back, they don't get the call back. They will go directly to the right person. That's the only thing I can offer. Does that answer your question, Micah? All right, cool. I'm sorry? Audience noise will not affect the voice quality, but other speakers will. And audience noise usually shows up as like bizarre audio artifacts in the output wave recording. Like, it'll almost sound like there's an audience to the voice clone. It's like the example I have of Brandon. You can hear it at the very end, like when it cuts off. It sounds like something's going on in the background, but it's all an AI thing generated based upon the input data. Jared. Yeah, so the quality limit case, Jared's question was, Is the quality limitation inherent to the tool set, or is it based on the input audio? And for this, it's very much based upon the model that we're using. You have to have at least 5 minutes of decently quality audio to get these kind of results. But like I said, Jared recorded these videos last month, and I just pulled them off YouTube, and yeah. Is it self-hosted? What's the name of the company or organization? Sesame? I have not heard of that, but that sounds very interesting. Please do. I will look into that tonight. That sounds very interesting.
How concerned are you somebody is going to clone your voice now?
Yeah, I don't care. You can make me say whatever. What's up? Oh yeah. What the question was? Are you concerned someone's going to voice clone you based on this? This is like my 24th presentation at SecDSM, and like all of them have been recorded. So like I don't.
What are the URLs for your other presentations?
YouTube.com/SecDSM. Forgive me, I can't hear you. I'm going to come closer. So the question was, can you control the tone perhaps by not the content, but maybe the punctuation or the wording used? Is that the question? Yeah, no, there's, at least from the level of access I saw, there was no way to directly control the tone. And I didn't really see any difference based upon like how I worded the sentence or what punctuation I used. Like if I used the exclamation point, that didn't do anything to the vocal inflection. So yeah, there's not a large degree of control over that with this particular model, the XTTS2 model. Less than a second, and that's for the short. Oh, sorry. The question was using a GPU to accelerate the processing. How long does it take? Yeah. Yeah, you type the text of what you want it to say, and then the GPU does it in like that. I mean, for 5 words, 5 sentences, it's going to be super fast. So the question is it trained first? And the answer is yes. So when you install that Python package and run it for the first time, it will download the model data from the internet. It's about 2 gigs in size, but like you don't have to do anything. All you have to do is run the library, and it will go out and download whatever model that you tell it to. Like the Python script over here, you can see that TTS line, initialized TTS. That string in there that ends in XTTS underscore V2, that's the model name. And this library just knows that it needs to go get that model off of Hugging Face when it's run. And it'll cache it. It won't do it every time. Does that answer your question? Anyone else? Yes, ma'am. Absolutely. The comment was an audience member is working with a external penetration testing team on a sort of deep fake attack against their organization. And that is the only legitimate use case that I mean, like as an offensive security tool for offensive security professionals, that's like the only legitimate use case for this software right now that I'm aware of. Yeah. Yeah, an unnamed audience member named Micah asked, mentioned that it was a concern at the elections. Do you have anything you can add to that? Did you see anything like that? Well, yeah, people may not even know. Yeah, that's a good point. The point was made that if someone was successfully tricked by this, you may not know, and it may have happened. So, yeah. Yes, sir. Yeah. I've heard little stories here and there of it happening, and I'm sure it's happening more than it's appearing in the media. The suggestion from the audience member was to have a safe word or a passcode that's shared with your family members, and should someone call and not be able to supply that passcode, you need to think about what's going on. That's a really good suggestion. I hadn't thought of that, but I think that would probably work pretty well. Thank you. Anyone else? Thank you for listening to my presentation. Take care. Have a good night.